Recorded as the sixth largest moon and 15th largest object in our galaxy, Europa finds itself slightly smaller than Earth's moon. Its equatorial circumference was approximately 9,000 kilometers, or 6,000 miles, with a diameter of 1,900 miles. Its mass, which was approximately 4.8 times 10 to the 22nd kilograms, is approximately 0.008 times the size of Earth. Its density, which is 3.01 grams per centimeter cubed, is in comparison to Earth's 5.5 grams per centimeters cubed and the Moon's 3.34 grams centimeters cubed. Europa's albedo is relatively high as well. Albedo, which is referring to its reflectiveness of light. Europa's albedo is 0.64, which is in comparison to our Moon's albedo of 0.12. This sleek surface of Europa is relatively young as well, estimated to be under 100 million years old. This theory supports the common hypothesis that Europa is an underground ocean, planet-wide, which is explained later in the presentation. With an orbit of 3.5 days around Jupiter, Europa is phase-locked, like our Moon, meaning only one side faces Jupiter. Europa is also tidally locked to Jupiter, like Earth's moon. Europa's orbit of Jupiter causes tidal flexing, which creates heat and energy, which can theoretically allow for an ocean to sustain itself under the surface. The moon's distance from the sun, 485 million miles, or 5 times the distance of the Earth to the sun, is the reason for the frozen ice surface that exists on Europa. But many scientists believe that the inside, underneath the surface, to be extremely active. Theoretically, the tidal forces could raise and lower the sea levels, which could create the heat and energy necessary to sustain an ocean underneath the surface. Europa was discovered by Galileo in 1610. German Simon Marius claimed to have seen it first, but failed to publish his findings like Galileo had done. Upon his observations, Galileo noticed 4 stars that stayed in close vicinity to Jupiter, and he determined that these objects were orbiting Jupiter, which later provided evidence that not everything revolves around Earth, an ideology which became to be known as geocentrism. Galileo's notice of such imperfections in the heavens prompted the study and the beginning of thoughts of heliocentrism, or how everything circles the sun. Since 1610, Europa has been observed regularly and visited twice by Voyagers 1 and 2. Missions are planned for the future as well, which will be later discussed in this presentation. Galileo himself noticed 4 moons, Ganymede, Callisto, Io, and Europa. Europa was the smallest, but also the closest, or the 6th closest of the closer moons. Jupiter's massive size collects and captures many of the objects, which orbit it like moons through gravity. After 1975, classifications of numerous of Jupiter's moons began to spread. These became to be known as Jupiter satellites. Europa's atmosphere is fairly limited. Oxygen and hydrogen are most prominent, oxygen more so than hydrogen. High radiation on Europa is caused by solar winds, which drag particles and trap them with the help of Jupiter's large magnetic field. Sometimes pockets of charged energy is at extremely dangerous levels and releases itself within Europa's vicinity. That radioactivity makes the surface constantly shifting and changing, and that radiation colliding with the ice surface creates the atmosphere by splitting the hydrogen and the oxygen and creating molecular oxygen. The surface temperature on Europa is around negative 102 degrees Kelvin, or negative 200 degrees Fahrenheit. This is explainable because of the distance between the Sun and Europa, which is again 5 times that of the distance of the Earth to the Sun, which makes Europa no doubt a chilly place. The layers of Europa are commonly agreed that it has a metallic iron core inside of a deep rocky mantle that consists of silicate rock, which is plentiful of minerals. On top of this is an ocean, which is believed to be kept around by tidal flexing, which creates energy, at sustained temperatures that is suitable for oceans, indicating that Europa is indeed active. And the ocean beneath is believed to be extremely salty, and that is covered by an even thicker crust of ice, which is extremely thick and concrete-like. Europa serves as an example of a place other than Earth where water is in existence. It is interesting to find water elsewhere because it is where water is in existence where life began here on Earth, or the idea of panspermia. The lineae, or the lines and cracks that you see along the surface of the Earth, if you refer back to the first picture of this series of slides, the lineae, or the cracks or streaks from the active surface, refer back to the opening side. These lineae are evidence of tidal stresses on Jupiter's surface. Some of these cracks can be distances of up to 12 miles wide. These cracks are theorized to come from the eruptions of warmer underground water, which are similar to how volcanoes erupt here on Earth, and that heat comes from the distance and the effects of Jupiter to Europa.
Europa's icy surface makes it one of the smoothest objects in our solar system. The surface is also seen as relatively young due to the surface's lack of craters, but many surface features are also prominent. Lineae are dark streaks found throughout the entire Moon's surface. Chaos regions are jumbled areas of cracks, ridges, and plains. Plexus are low curved ridges. Large rings are ring-like impact structures, and maculae are dark spots. Europa's water content is thought to be twice that of Earth's. The ocean is believed to be 100 kilometers deep and rich in either sulfate or chlorine. It was once thought that the ocean was made up of magnesium sulfate, but observations have indicated otherwise. The chlorine salts in Europa's ocean support the possibility for life because Earth's oceans are also salty. Earlier this year, scientists detected chemicals on Europa's surface that came from the ocean beneath the ice surface, indicating that the ocean and ice surface do communicate with each other. This suggests the possibility for life. Scientists believe ice spikes may be present at the equator of Europa. They have looked to dry, cold areas like the Andes Mountains where spikes have been known to form. Ice spikes can form in clean and dirty environments. It is hoped that one day we might be able to land on the surface to study Europa's features. Unfortunately, since Europa's young surface is constantly changing, it is difficult to plan a safe landing spot for future study.
Although photographed on previous flyby missions, NASA's Galileo spacecraft was the first attempt to directly study Jupiter and its moons. During the almost 10-year mission, Galileo was able to successfully explore the moons of Jupiter up close, including Europa from 1997 to 1999. Galileo's instruments were able to detect the unique magnetic field signature of salty water, confirming the existence of a subsurface liquid ocean. Galileo was also able to identify a thin atmospheric layer of Europa, known as an exosphere. The exosphere is primarily composed of oxygen, and is the result of ion bombardment and sublimation of Europa's surface. Although no missions to Europa have yet to reach a developmental stage, concepts have been proposed by multiple space agencies. The European Space Agency has recently announced the start to a program called the Jupiter Icy Moon Explorer. This mission calls for a spacecraft to be sent to study the Galilean moons of Jupiter, including Europa. The spacecraft is not expected to actually land on the surface, but rather gain useful data by means of several flybys. Its goals will be to analyze the composition of non-water material, determine the ice shell thickness, and lastly study the formation processes of the surface features. NASA is also working on a concept for further study of Europa, and have named the program the Jupiter-Europa Orbiter Mission. With this spacecraft, NASA intends to fly by and actually enter into a European orbit. The Jupiter-Europa Orbiter is expected to study the composition and surface features of Europa, in addition to determining the approximate depths of the icy crust and liquid ocean. Exposure to the harsh space environment on the exterior of Europa forces the search for life to continue below the surface. Human technology is not quite at the level necessary to engineer a mission to penetrate the icy crust and explore the ocean for evidence of life. However, possible concepts have been considered. The first stage of exploration will involve penetrating Europa's thick layer of solid ice. Several methods have been thought of, including penetrating probes which crash land into the surface and cause craters, drilling methods to bore holes, and melting techniques to sink through the ice with the aid of heat and gravity. The second stage of exploration will begin upon reaching the liquid layer of Europa. The spacecraft must include a probe capable of navigating through the liquid saltwater. At present, scientists have no idea what to expect upon entering Europa's ocean, but the foremost locations to search for life would be possible heat vents at the seafloor. These would be similar to those found at the deepest crevices of Earth's oceans. A large concern with searching the ocean is maintaining contact with the spacecraft at the surface in order to relay any gathered information back to Earth.